Hi guys, we've been doing a lot of road trips. We're going to do another road trip, and this time we're going to be in an LS3, a real LS3 with no variable valve timing, higher compression, and no active fuel management. We're in a relatively heavy JK, upgraded axles, 40-inch tires. You know the routine. It's also black, and it's hot out here. It's showing 112, and that's probably pretty accurate. The last few test drives we did were in LTs, and you know what the economy numbers were. Let's see what this LS does and how it handles the highway. Now my guess is on the grades, this transmission is going to downshift, where in general the LTs don't. The economy I don't think is going to be quite as good as the LT, but there's a lot of variables involved with that. Not only the weight and the size and the aerodynamic drag, but how you drive and the quality of gas. So just take that with a grain of salt. We'll see what it does. I didn't document much of the drive up here. It was very non-eventful. But I did use a different strategy than before. Rather than just go the speed limit, 80 miles an hour, up hills, down hills, I backed off a little bit. I know that these Jeeps get better economy when you go slower. In fact, I think Jeep says for every 5 miles an hour you go over 65 miles an hour, you lose so many percent per miles an hour. I forgot what it was due to aerodynamic drag. So I backed off to like 70 to 75, and actually the results were quite surprising. As you know, this Jeep is kind of heavy, but it is conservative. It doesn't have a light bar and it doesn't have stuff hanging off everywhere, but it is on 40s, and it does have some steep gears. We're cruising 2,500 RPM at 80, maybe 2,400 RPM at 80. The LS3 has to be looked at differently than the other LS engines. The LS3 did have higher compression and more aggressive cam, which means it's a little more comfortable at the higher revs. So the end result was I got good economy, at least what I consider good economy. I guess we were about 16 miles to the gallon. Now we'll document it more carefully here on the way back, but yeah, about 16 miles to the gallon. A while back I did a video where I talked about open loop, closed loop. So when you're going up a hill, if you're under enough of a load to kick into performance enrichment, it can really hurt your economy. And I've had several customers tell me since that video that they've really improved their economy by watching that parameter. And that's exactly what I did. I kept it at a open loop. And I will say that this LS3 having the steeper gears didn't downshift as much as, let's say, an L94 with tall gears. Now I think at the end of the day, the L94 probably would get similar, if not better, economy with the taller gears, just because the engine's revving less. But this LS3 does just fine pulling these 40 tires at the higher revs, because it's actually designed to rev higher than the L94. Now I know you're going to say, what would have an LT done? As you know, we did an LT where we averaged almost 18 miles to the gallon with 37s, and another where we averaged, I think, 14 in a Jeep that had just all sorts of stuff on it, and we were pushing it. So I think if the LT was in this exact vehicle with tall gearing, it would definitely outperform it as far as economy goes. And we're not talking 5 miles to the gallon. We're not going to be getting 20 miles to the gallon, 22 miles to the gallon with this vehicle. But I think it probably would have got 1 or 2 miles to the gallon better. Remember, all an internal combustion engine is an air pump, and how efficient it is based on the valve timing, intake, exhaust restriction, all that stuff. So you can only get so much. I had some crazy ideas years ago how to make internal combustion engines more efficient by capturing the lost heat. Remember, a lot of the heat goes not only through the cooling system, but out the exhaust, and it's just wasted, and heat is energy. So if we could harness that heat, we could reuse it somewhere else, maybe to charge an electrical turbine or steam. But that's getting off the subject. Engineers in Detroit and around the world are restricted by a lot of things. They could get a lot better of economy out of our vehicles if they were unrestricted. Things like lean cruise could really pick up the economy in an internal combustion gas engine, but then the emissions goes up. They're required to put out a certain amount of power, and these vehicles are now getting very heavy. I don't think you realize how heavy these vehicles are with all the new safety equipment. I remember back in my day, if a vehicle was in the 2,000, 3,000 pound range, that was kind of expected, and if it was heavier than that, then it was a pig. But now, you know, these Jeeps are pushing 5,000 pounds. My wife's minivan is over 5,000 pounds. So these engineers are burdened with vehicles that are a lot heavier. They have to put out the performance that today's roads require, which is really 80, 90 miles an hour if you have to pass. They have to meet federal emission standards and California emission standards, which are really tough. So I think overall they're doing a great job, considering we have engines that are more powerful than we had in the past. that are getting better economy than we have in the past, in vehicles that weigh more and are safer than in the past. Our Jeeps are kind of a different category, because if you've got a Toyota with 27-inch tires that weighs 3,200 pounds and is as aerodynamic as a ballpoint pen, it doesn't take a whole lot to make that vehicle get 20, 30, 40 miles to the gallon. But when you take a Jeep with 40-inch tires, and one tire can weigh 200, 250 pounds with a wheel, you're pushing 1,000 pounds of wheels and tires. You raise it up in the air so it's as aerodynamic as a brick. Then you got all your stuff hanging off, your light bars and your winches and bumpers and skid plates and everything else. Now we're starting to talk engine load. And traditionally over the years, if something was really heavy or had to tow a lot of weight, you just put a diesel engine in it. And that's still true today. I mean, you look at these semi-trucks with diesels, it's amazing how much weight they can haul. Even the 1 ton and 3/4 ton pickup trucks now that you can get from Chevy, Ford, and Dodge, these things are pulling it almost as much as the semi-trucks were a few decades ago. So the diesel engine is definitely a viable option. But the diesel engine has some restrictions in these light-duty vehicles. One, when you choke them down with light-duty emissions, it really takes the heart out of the diesel. While you still have some of the benefits, diesels like to run at a constant RPM. They like to be unrestricted. They don't like to have all these exhaust scrubbers and exhaust gas recirculation systems and filters. When you add all that stuff, the efficiency starts to decline. Then you put it in a stop-start situation like around town, and again, diesels like to get in the open road and run at a specific RPM over the long haul, and that's where these semi-trucks run, and that's why they're so efficient. But when you put it in a light-duty vehicle that drives around town, there are diminishing returns. And that's not to say that a Jeep with a diesel engine can't get over 20 miles to the gallon. They can. I know a lot of guys with the Grand Cherokees that are getting that economy. But the cost of these engines are considerably more than the gas engine. The horsepower of these engines are considerably less than the gas engines. The maintenance, just everything you look is going to be more costly with the diesel than it is with the gas engine, and you're really not getting the same level of performance. So when you add it all up, the diesel does seem to be a dying breed in light-duty vehicles today. I know that Europe was really big in them for a long time, but gas motors are getting to be so efficient. Fiat has actually made a lot of progress with the gas engines in the Chrysler vehicles. Not that guys like these little 2-liter engines, 3-liter engines, but if you compare it to what we had 20, even 10 years ago, they have made a big difference. The Pentastar engine, for example, is pushing 300 horsepower, where the 3.8 engine, which is larger than the Pentastar, was averaging about 200, 220 horsepower. And you all know that I feel that a big part of the performance in these later model vehicles isn't just the engine, it's the transmission. I can tell you back in the day in Los Angeles when I was hot rodding, if we had these transmissions, it would have changed things. I remember a lot of guys running the power glides, or the power slides as we used to call them, in drag racing even up through the 1980s, because there really wasn't anything that much better. But today with the launch control and high gear transmissions, it really would have changed the game. So what is this video about, other than me being bored on the road and wanting to ramble? I think what it's about is, if you have an older generation engine like this and you still want to get good economy, and you have a JK that's heavy and you got 40-inch tires and 1 tons, I think you can still get it. You have to do a couple of things though. You have to drive with economy in mind. That means don't use the skinny pedal as a switch, on and off. Modulate it. Only use it as much as you need to get as fast as you need to go. I remember in the 80s there was a big debate whether jackrabbit starts were better than accelerating slowly. What that means is launching from a red light hard, getting up to cruising speed, some argued got you better economy than if you lazily accelerated up to the cruising speed. I think the answer is somewhere in between. I've never actually done testing on that. But what I do know is if you have a lead foot all the time, anytime you want to accelerate from point A to point B, you're wide open throttle, you're going to kill your economy. So just use the throttle. So modulate the throttle with some reason. And yes, with the V6, a lot of times you had to floor it just to get to point B the way you needed to get to point B, but you don't have to do that with the V8. One of the nice things about the V8 is just how relaxing it is. I'm cruising along here at the speed limit with I could be sitting in a couch in my living room. That's how comfortable it is. And if I have to accelerate, I can go around these vehicles with ease. So there's no reason to be Ricky Road Racer. So that's number one. Number two, run good quality gas. Whatever your engine requires, run it. I get this question all the time. Can I run this gas in that engine? Engines are designed for a certain octane rating. Octane is anti-knock. It's this resistance to knock, or pre-ignition. Pre-ignition is when the charge in the combustion chamber goes off before the spark plug does. And the reason it does that is because you have high cylinder pressure. If you put the engine under a heavy load, you're heating up that combustion chamber, and what can happen is the ignition can start at some point in the combustion chamber, usually off of some sharp edge of a machined part on the head, and unfortunately the flame propagation at that point is not as designed, and that can cause all sorts of havoc inside your combustion chamber. And what you end up hearing is, they call it knock, they call it engine rattle. Some guys say it sounds like marbles rattling around in your engine, but what it is it's pre-ignition. So you don't want that. By running a higher octane fuel, it will limit pre-ignition. High octane fuels became a big part of piston engine technology in World War II. A lot of experts say that it was the high octane fuels that allowed the American engines to outperform the German engines. When we're pushing 20, 30, 40 inches of manifold boost, if that engine pre-ignited, it would explode, it would fail. So our fuels allowed us to run really high output on these piston engines, especially when in emergency power. It wasn't until the end of the war, when the Germans started to formulate synthetic fuels, that they could catch up to us. But that trickled down into hot rod technology, and you guys all know that in the hot rod days, there was a lot of stuff going on with fuel, polypropylene, nitromethane, but that's not what we're talking about. We're talking about gas that you can get out of the pump. So getting back to number 2, run the octane rating that your engine is designed for. Now this LS3, I want to say it's high compression at 10.7, but if you compare that to an LT at 11.5, that sounds like low compression. But if you compare it to the dark days of the 8-to-1, 9-to-1 engines, and the LSs that were 9-to-1 and 10-to-1, then this is a relatively high compression engine. So what happens is, if you have a higher compression engine and you put high grade fuel into it, it's going to allow that engine to perform the way it's supposed to, because now the octane scalars are going to go up. And yes, you have low octane tables and high octane tables, and then you have ultra fast, ultra high speed knock sensors. And these knock sensors are so fast that they can pick up spark knock on each individual cylinder, and then they can actually change the spark output for each individual cylinder, just as the fuel injection system can. I remember working on the Buick Grand Nationals in the 1980s. That was the turbocharged V6, when they came out with the knock sensors, and they were really primitive. You could take a crescent wrench and wrap the side of the block and just watch the ignition timing drop off. Well, we're light years ahead of that now. So if those knock sensors are constantly knocking because of low grade fuel, then it's going to pull that octane scalar back and back, and you're going to start losing performance, you're going to start losing economy. So if you put the proper fuel in it and the scalars crank up, then you're going to be getting better economy and better performance. So a lot of guys don't realize that. Let's say you go to the gas station and regular gas, or 87 octane is $3, and premium 91 is $3.30. So you're paying 10% more, but the reality is, in a high compression engine that requires it, you're probably going to get 5 to 10% better economy, because the engine's going to run the way it was intended to. So you're not really losing that whole 10% or that 30 cents. Now if you put that same fuel in, let's say, a 5.3 or a 6-liter LS with low compression, that engine didn't require the higher octane fuel, so you're not going to see the same gain. That engine's going to be happy running on just the 87 octane. The nice thing about the 5.3 or the 6.0 is you can pretty much put anything in it. So if you do find some 85 octane, like I'm up in Utah right now and we got some pretty low grade fuel up here, that engine's going to run it up with no problem. And really, what fuel you use is a big subject, but I want to kind of limit it because it could turn into all sorts of chemical discussions. So let's just say that run the octane that your engine is designed for. Let's talk about number 3. If you got a vehicle that's lifted on 40s, you got light bars hanging out, rock rails, full skid plates, all this stuff, you got it 6 inches up in the air, there's a lot more energy required to push that thing through the air than there is a Toyota Prius. Really, the only thing you can do to combat that, short of removing those items, is to slow down, because it's a geometric progression. Now, these numbers aren't scientific. I'm just trying to make an example here. If you were to go 60 miles an hour and the drag was A, then you went 66 miles an hour, the drag would not be A plus 10%. The drag would be more like A plus 20%, because the faster you go, as the airplane guys know, there's a geometric progression of the amount of drag. So just slow down. That's really the only solution if you don't want to remove some of these components. On that note, you can remove some of the components for a long road trip if they're easily removable, like light bars, or just design your Jeep. And I had a Jeep I did recently. I think the guy did a great job. He sunk his winch in almost fully into the bumper. His lights were recessed. Even though the Jeep had all these accessories on it, they weren't gaudy and they weren't hanging out in the Airstream. Now here's a big one. You guys probably don't think it's that big of a deal, but tire pressure. You know that it's been federally mandated that vehicles now have tire pressure monitoring systems, just like the JK does. The early JKs were pretty primitive. They basically set an alarm off if you went under pressure. They didn't tell you what the tire pressure was on each tire, which the newer JKs and most new vehicles do. But tire pressure is critical, because if you have a 40 running at 20 PSI or 15 PSI, that's going to create a lot more drag than a tire running at 30 PSI or 35 PSI. You can do rolling resistance tests. I used to do that with Chris Jacobs out in Eagle Rock. We had a little course set up, and under perfect conditions, you would let the gas off, you'd put it in neutral, let's say 60 miles an hour, and then coast down, and it would tell you how much drag the vehicle had. We did this with, believe it or not, when AMSOIL was first becoming popular in the 70s, we did this, and we would change the engine oil to the full synthetic AMSOIL. We would change the differentials, the spindle bearing grease, etc., and then we would log it, and we could pretty accurately with these coast down tests, you know, not like laboratory conditions, but within a few percent, we could tell how much improvement there was. And there was an improvement with the synthetic oils, and I think that's why pretty much everything now is running synthetic oils. So you can do your own coast down test. When you pass a certain landmark, let the gas off, coast to another point, see what your vehicle's speed is. Put an extra 10 pounds of pressure in your tires if you're running at 20, and do it again and see what your speed's at. While we're talking about tires, the selection of tires also very important. If you have 37s and they're 13.5 inches wide, made out of bubble gum, and a hot day, and yeah, I've been pushing 100 to 110, even 118 on these road trips I've been taking, and that asphalt is well over 120 degrees, and now you got a tire made out of bubble gum. I know that my guys even have a hard time pushing some of these vehicles around in the shop with those tires. Those tires don't just miles per gallon, they kill it. I had a customer who was getting about 9 miles to the gallon with some of these bubblegum tires, and he liked them because he was running old riverbeds that still had water in them and rocks, and these things really stuck and got him where he wanted to go. But on the highway, they were horrible. He changed them out to some all-terrain 2s and went from 9 miles to the gallon to 13. Yes, 4 miles to the gallon improvement just by changing his tires out. And he was no longer going berserk on the highway with the tires making all that noise. So tires can have a big effect on your economy. And you know, guys, when guys say, what kind of mileage can I get? There's just so many variables. What tires do you have? What tire pressure do you run them at? How much drag does your Jeep have? What kind of fuel are you running? All these things come into play, and that conversation can take a long time. So my standard answer is, whatever you're getting with the V6, in that configuration, that tire size, that weight, that aerodynamic drag, you can usually expect 1 to 2 miles to the gallon better with the V8. With 40s, you can expect more than that, because the economies of the larger engine really come into play with the heavier vehicles and more drag. I have to qualify that statement. If you were to drive at the same speed, that remains true. Like, I just passed a JL a little while back trying to get up this grade, and he obviously chose to slow down. Now, I know he was going faster on the flatland, but he slowed down on the grade. Whether he wants to get better economy or the engine was revving up, whatever it may be, he slowed down and I didn't. So when I make that statement, that's for all things being equal. You drive the same speed, the same highway, the same lane, 1 to 2 miles per gallon better. I'm going to say 3 to 3, maybe 4 miles per gallon better in the heavier JKs. But here's the deal. I'm not going to slow down on this grade. I'm going to keep going 70, 80 miles an hour, whatever the speed limit is. So now I am going faster than I would with a V6. And if you do that, then what I find is, I find that the economy is better than the V6, and you get to go faster. If you got an engine that's running really hot, the combustion efficiency isn't going to be as good. You got your cooling fan screaming. It's just not going to get the economy than if it's set up right and you're allowing the airflow. And look at that, we dropped 10 degrees in less than a mile going down that hill. Now we're going up a hill again. We're probably going to see it go up a little bit. Please have sufficient coolers to do the job. I've got a Jeep in the shop right now that has a stock radiator and a stock fan with a 6-liter, which isn't a high compression engine, but he's got screed mesh, and while it was fine from where he came from, I can't drive that vehicle down the highway like I'm driving this vehicle. I was hitting 245, 250 degrees, and I had to slow down. the 6L80, 8L90, and 10L80 are all low friction transmissions. You can't compare them to the 4L60, 4L80, 42RLE, WA580. We find those transmissions build a lot more heat up. Henceforth, you have to run larger coolers. And again, make sure you have proper airflow. The ideal goal would be for natural airflow coming through the grill and over the vehicle to cool the engine and the transmission and the air conditioning without having to waste energy. Some guys say, well, the cooling fan doesn't use a lot of energy, and yes, it does, because that cooling fan has to be driven through electricity, and the alternator has to supply the amperage to the battery so that that cooling fan can run, and that can be 10, 20, 30, 40 amps, and over several hundred miles that can add up to a mile per gallon decrease. So yes, it does. And you can see that the natural airflow in this Jeep is working really well. At 210 degrees, that fan is essentially off right now, and I do have my air conditioning on, but the natural flow is keeping the condenser cool. So essentially the fan has turned off in this vehicle, even though it's a black JK on 40s. And I can tell you, I drive vehicles on 32s with a grill block. They got a license plate in front of it. They have angry eye grills. They have grill inserts inside of that. Then they decide to put a couple of lights or a light bar in front of that. And I see these fans screaming at 70%. Even on a lightweight vehicle. So it just goes to show you how you can help your economy and help your vehicle last longer by paying attention to those things. All right, guys, so I couldn't stay under the speed limit. It's a beautiful day out there other than the smoke from the fires, and we got long distances to go. So I'm back up at 80 miles an hour, and I'm probably gonna stay here for a couple of hours, but when we do get into situations like going up grades, I'll back it off. I don't think it's going to affect the economy too much, but there's no reason we can't cruise at 80 miles an hour. Do I think we would have got better economy at 75? Yeah, of course, but this LS3 just wants to go. We're just going to let it cruise here at 80 miles an hour through to Beaver, I'm thinking. Well, here we are in Beaver. We've gone just a bit over 200 miles with this LS3 JK from Salt Lake. Actually, a little bit more than that. We used about 2/3 of a tank to go over 200 miles. I'll do the math and tell you what the mileage was. We did end up going about 80 miles an hour most of the way. It was this LS3 just wanted to run. So here's what we have on this JK. It's actually pretty clean. You can see there's no light bars and gaudy stuff hanging off. We got a shorty bumper. We got a couple of LEDs down on the hoop and the windshield, but not much else. And I think you can see one of the reasons it's running cool, even though we got a lot of bugs and debris up here in that small tranny cooler, it's still staying cool. We do got some Nitto 40-inch tires, which of course are pretty big. Looks like we got a King coilover setup on this Jeep. Steel rock rails, some pretty abbreviated fenders, and that's about it. So let's see what this thing did. So that's what we got, guys. 15.8 on that last leg. It was really good weather. We didn't run into any wind or rain or anything, and the temps were staying below 100. Getting a little boring here in the construction zone. We're only going 70, 75. And I know that a lot of you guys are techno nerds, so we can look at the good old scanner. Now, I did plug in the Bluetooth for Torque, the app Torque, because it's a lot easier to see than the little Aeroforce gauge. And this is my temperature page. A lot of interesting things here. You notice the knock retard is actually active, and we'll talk a little bit more about that in a minute. So our intake temps are reasonable. You know, we're pushing 100 degrees out. The trans temp is not showing. For whatever reason, on Torque and the Bluetooth app, the trans temp comes and goes. I think it just has to do with the way the CAN communication works, but it'll pop in now and then. But we were running between 180 and 190 virtually the entire trip. Coolant temp's good. Oil temp's showing a little high, and I've said before, that is a calculated value, so take it with a grain of salt. It's unlikely that the oil temp's at 260 and the coolant temp's at 204, but I think we might fit a engine oil cooler on this vehicle just because it's a large, heavy JK and it's black, so that'll bring that down. Our AC pressure, as stated before, is really not that high. I think it's completely natural airflow that's keeping the condenser cool. Like we're going downhill right now, and you're going to see that coolant temp come down. GM doesn't really wind the fan up till 226, so we know the fan's not on for the engine, and it's probably not on for the AC. It's just staying there. So essentially, our fan has shut off, which is great because we're not using that energy. We're not wearing the fan out. With the large 19-inch diameter opening of the SS fan, it allows pass-through air, where a lot of these guys get the dual fans with a 12-inch. Those things are just blocking airflow when you don't need the fan. So you can see we're already down into the 190s on our coolant temp. So that's a good thing that we're using the natural airflow. Our voltage is, on our LS kits, we use the stock Jeep alternator, and it is smart charging. So that voltage is being controlled by the TIPM, or actually the computer and the TIPM, the PCM and the TIPM. You want to see it in the 13s, maybe the low 14s. You don't want to see your voltage in the 11s or 12s. The early LTs that we did before we had control of the alternator, we were seeing that. We were seeing 12 to 13 volts, and it was because we didn't have control of the GM smart charging system. But now we do. We got to keep those cat temps up so that they do their job and combine oxygen with bad elements to create good elements. The one thing on this page that's concerning for me is that knock retard. Now I drove it the whole way to Salt Lake, not looking at the knock retard, and got great mileage. Now part of this might be because I just got gas in Beaver, and I don't think it's the highest quality gas. So I'll keep an eye on that, and if the knock continues, we'll back it off just a little. Let's go to this page, and like I said earlier, we're going to talk about the knock retard. I think part of the issue with the knock retard here might be the fuel, because look at the fuel trims, long-term fuel trims on the left. They're running quite a bit positive, more than I'd like to see them. That could be because of the gas that we just got, or that could be because of a mass airflow calculation that's not right. Now notice that we're flatlining on our O2s right now. We're going up this hill. I don't know if you remember, but on this same hill, the LT was not flatlining. We weren't going into performance enrichment. So we're in performance enrichment right now on this slight grade, and what that tells me now is I might just back it off a little bit. We can back off the KPA, that is the map or intake manifold pressure. A lot of guys will bring it down and down and down until you're practically in performance enrichment all the time. But we'll probably bring it up to about 85 kPa. So you have to be under a heavy load. Like now the grade isn't as steep, and you can see the O2s went back into closed loop. Here we are at the last leg of the trip. We went about 900 miles, and this LS3 never missed a beat. We got between 15 and 16 miles to the gallon, and that was with me not pushing it, but going the speed limit. So I thought that was really good. Stay tuned.